Well, hello class. This video is going to help with section 12.5. Sometimes it was 5.5, but it's the fundamental theorem of calculus. So we're still dealing with integrals, and now this is a huge idea for being able to calculate that definite integral without a sum, okay? So here is the total idea for this. So pause, get this written in your notes. If the function f is continuous on some interval a to b, and capital F now is going to represent the antiderivative of the function f, then the following is true. So if we have an integral that goes from number to number of some function, we can find the antiderivative of this function and put in this value b, and put in the value a, and subtract them, and that will be your answer. So let me show an example of that, or a couple. So here's my first one. What if f of x is equal to 100? Okay, f of x is equal to 100. Where's that button that, is it this one that kind of, yeah. I was trying to remember which one made it focus a little better. Okay, so what would be the antiderivative of this? So this is my little f. The big F of x, the antiderivative would be to add an x on there, and then divide it by 1, the exponent, which we don't really have to do because it's just a 1. So this is my antiderivative. I'm leaving off the plus c. Okay, this is an estimation or as close as we can get to the value. And then we know this one, we're going to say goes from 1 to 6. So I didn't quite write it in integral form. I could, it would be 1, 6, and then this would be 100 dx. This problem and this problem are exactly the same. You would take the antiderivative, which I did here, make it 100x, and we have our integral here, same here. And from here, we then put in that value of 1 and that value of 6. So we'd have 1 times 100, or 100. Down here, we'd have 6 times 100, or 600. And then the fundamental theorem of calculus says then subtract. So you subtract your top or your second one first. So 600 minus 100 is going to give me 500. So the area under the curve between the numbers 1 and 6 is about 500. Okay? All right, so let's look at some definitely getting harder ones. So what if, I'm going to write it in this notation this time, our integral notation. I have x plus 5 dx. So I'm going from 0 to 4, and I have x plus 5 dx. Okay, what is the first thing I want to do? Well, I would think of this as being my little f. So my first thing is to find the antiderivative, right? So my big F. Okay, so I know this x here will become squared. So x, you add 1 and then divide by that number that you made the exponent, plus this would become 5x. Dividing by 1 doesn't really matter. Again, we don't really have to use, or we kind of ignore the constant, whatever it would have been. We don't know it, we can't use it. Okay, so then we're going to find f of 4. So we would go 4 squared over 2 plus 5 times 4. Okay, that's going to be 28. You can pause and make sure you know that one. So then this one is 0 squared divided by 2 plus 5 times 0, which is 0. Okay, so then we're going to do the top one, 28, minus the bottom, which is 28. Okay, not just the biggest minus the smallest, top minus the bottom, because it could be a negative answer. Okay, let's try. I'm gonna flip this over. It's my third example. Let's try going from 1 to 2 of 2x plus 3e to the x minus x, or 4 over x dx. Okay, so we're using more of those antiderivative rules we've been learning. So if we look at this one, when we go to find that capital F, okay, what's the derivative of 2x? Excuse me, antiderivative. Yeah, it's going to be 2x squared divided by 2. We'll simplify in a minute. We just want to get the main idea down, and then we'll simplify. Okay, then what are we going to do? We're going to look at that 3e to the x. So positive, this constant stays there, and the derivative of e to the x is e to the x. So this one stays 3e to the x. If it would have had something up with that x, it would have made it a lot uglier for us. Okay, then what are we going to do for the antiderivative of 4 over x? Well, that's that case where it'd make us 0 if we brought the exponent as a -1. So that's where that keys us to, oh, it has to be a natural log. So we're going to keep the constant, and then it's going to be a natural log of x. Okay, that part's a little hard to remember. Plus c, we'll leave off that. So then let's put in our first value here of 2. So then we're going to put in 2 times 2 squared divided by 2 plus 3e to the 2 minus 4 natural log of 2. Definitely going to be a decimal. Definitely need your calculator. So plug that into your calculator, and I got about 23.395. Hopefully I did that right when I did it. Okay, then we have to put in that bottom number, that 1. So we would have 2 times 1 squared over 2 plus 3e to the 1 minus 4 natural log of 1. And I get about 9.155. Again, pause the video, make sure you actually get these calculations. And then our final answer will be subtracting the top one minus the bottom. So 23.395 minus 9.155 will give us an answer of 14.24. 14.24. All right, so we're doing the antiderivative. We're putting answers in. So they do get a little bit harder with our antiderivative. Let's do one that makes you use your u and your du parts. So let's see here. What if I'm going from -4 to 1 of the square root of 5 minus t dt? Dx, dt, same thing. Okay, so what do we start with? Well, we want to probably write that as an exponent for the square root, which we should know by now is a 1/2. And then to do the antiderivative, we're adding 1 to that 1/2. But I want to think of it as u is going to be 5 minus t. Okay, so du is going to be -1. Okay, and I don't see a -1 there. So what are we going to have to do? We're missing that -1 on that du. We're going to have to divide by -1. So let me show you what I'm thinking here. So this is the same as 5 minus t to the 1/2, okay, dt. Then if we switch it over to the u, we're going to think of it as u to the 1/2 du, and then we're going to have to divide this by the -1 that we didn't have out front. Okay. Okay, so take the 1/2, add 1, and that's going to give me 3/2. Okay, so I'm going to have u to the 3/2 divided by, we have a -1, and we'll have a 3/2 down here, du. Well, no, the du disappears. All right, so let's simplify that. Okay, so really this is going to be a negative 3 over 2. And then we have to flip it over so it becomes 2 times this u to the 3 halves, but u is just 5 minus t, and that's to the 3 halves over now just the 3, and this would be a negative. Or the negative could have been on the 3. Basically, what did I do? Flipped this over, so the 2's there, the 3's there, the negative is here or here, either way, just one negative, and I exchanged the u for u up here, our 5 minus t. Okay, so ugly, but we got it. Then what do we have to do from here? We have to put in our values of negative 4 and 1. So this is our capital F here of u, or capital F of t. So we're going to do capital F of 1 and capital F of negative 4. So when we go to do the 1, it's just going to be negative 2 times 5 minus 1 to the 3 halves divided by 3. I definitely want to put that into my calculator. I think they make you do this one in fractions, though. So calculate the top and then the bottom. The top, I got negative 54 thirds. Excuse me, the top I got negative 54, and then over thirds. Okay, and you could put in a fraction like this. I mean, it really is this to the third square rooted, but you can put it in just like you see it. So the negative 4, oops, this is 16. I wrote the wrong one. I should calculate it on my calculator and make sure, because I can. So negative 2 times 5 minus 1 is 4 to the power of 3 halves, and ta-da, negative 16 thirds. Okay, the next one would be negative 4, so we have negative 2. 5 minus a negative 4 is going to be a plus. 3 halves divided by 3, and this one's the negative 54 thirds. Decimals. Okay, then over here, we're going to take our top one, which is negative 16 thirds, and we're going to subtract off the bottom one, which is negative 54 thirds. So you end up having a double negative or a plus, and this ends up being 38 thirds, which is about 12.67. All right. I'm going to look. I think this is like, I mean, it's the same idea. The biggest problem you might have truly will be finding your antiderivative. That's, I mean, if you can't get the antiderivative, you'll be stuck more with that than anything else. So function given the interval, what promise on this? Let, therefore, integral. Find the average value. The average value is different. Okay, I'm going to go ahead and pause there. There are a lot more examples in the program. This is the main idea. It'll get you started, and then the problems you get stuck on, you can look for an extra video for, or you can easily come in on my tutor time. All right?